Hello friends, my name is Vidya Patil. Today we will see the chapter Elasticity. These are the topic contents: introduction, definition of deforming force, restoring force, elasticity and plasticity. Factors affecting elasticity, stresses and its types, strains and its types, and elastic limit, Hooke's law. Now we will see the introduction of elasticity. Friends, we know every material body consists of atoms or molecules. Under action of force, if the position of atoms or molecules are unaltered or not changed, then that body is said to be perfectly rigid body. But no body is perfectly rigid. In other words, in every body, the position of atoms gets changed in large or small extent. It means that under action of force, body changes its shape or size or both. In case of few bodies, shape and size recovered or on removal of applied force, and in case of few bodies, they cannot recover or regains. On the basis of this fact, bodies are classified into two types, that is elastic body and plastic body. Now the deformings, we will see some basic definitions. Deforming force. The force applied on elastic body which is responsible to deform is called deforming force. Restoring force which is responsible to restore original size and shape of the body. Now elasticity. Elasticity is defined as the property by virtue of which body regains its original size and shape on removal of external deforming force. For example, when rubber band is stretched, its length increases, and when it released, it regains its original size and shape. One more example is when a spring is loaded, it gets deformed, means its length increases. But on removal of load, the spring regains its original length, that is elasticity. These are the elastic body. Rubber band, ball, golf ball, all are examples of elastic body or elasticity. Now plasticity. Plasticity is defined as property by virtue of which body does not regain its original size and shape on removal of external deforming force. Examples are clay, wax, mud, plasticine. These are the plastic bodies. Inelastic ball, clay. Now there is one question for you. Divide the following objects into two groups as elastic and plastic body. Paper, glass, steel, chalk, clay, rubber, brass, copper, paper, mud, spring. Now elastic bodies are steel, rubber, copper and spring. These are the elastic body, and plastic bodies are paper, glass, chalk, mud, clay, etc. Now we will see the factors affecting elasticity. These are the factors: effect of temperature, effect of annealing, effect of hammering and rolling, effect of impurities. Now we will see all these factors one by one. First one is effect of temperature. As the temperature of material increases, the elasticity of material decreases and vice versa. Second effect is effect of annealing. In the annealing process, the metal is heated and cooled gradually. It's called as annealing. Due to annealing, the smaller crystal present inside the material gets oriented in one particular direction and softening of the material takes place. So due to annealing, elasticity of material decreases. Third factor is effect of hammering and rolling. In this, the metal consists of small crystal grains. Due to hammering and rolling, the crystal grains breaks up into smaller units and it increases the elastic properties of material. And the last factor is effect of impurities. The impurities added in the metals, the strength of the material increases and elasticity of material also increases. But in some cases, by addition of impurity in the material, elasticity decreases. Now the stress and its types. Stress is defined as internal restoring force per unit area, and restoring force is equal to applied force. So stress is equal to applied force upon area, and that applied force is denoted by F and area is A, and unit of stress is force is measured in Newton and area is in meter square, and in CGS system it's dyne per centimeter square. Now the types of stress. There are three types of stress. 1. Tensile or longitudinal stress. 2. Volumetric stress. And number 3. Shearing or shear stress. Now we will see all these types one by one. First one is tensile or longitudinal stress. Tensile stress corresponding to increase in length. So tensile stress is equal to applied force upon area, and again force is equal to F upon area is equal to A, and that F force is nothing but weight W, and W is equal to mg, and area is equal to pi r square. So the formula for tensile stress is equal to mg upon pi r square, and again the unit is Newton per meter square in SI system and dyne per centimeter square in CGS system. Second type is volumetric stress. Volumetric stress is when the external force applied, it changes its volume, then it is called as volume stress. So volume stress is equal to applied force upon area, and that applied force is nothing but change in pressure, and it is denoted by dP. And the unit is again Newton per meter square or dyne per centimeter square. And third type is shearing or shear stress. Shear stress is defined as the stress developed in a body due to change in shape of the body without change in its volume when external force is applied tangentially or parallel to the surface of the body. So shear stress is equal to tangential force upon area is equal to F upon A, again unit is Newton per centimeter square or dyne per centimeter square. Now the strain and its types. Strain is defined as it is the ratio of change in dimension of the body to the original dimension of the body. So strain is equal to change in dimension per original dimension. These are the types of strain. Tensile or longitudinal strain. Second type is volumetric, and third one is shearing or shear strain. Now we will see the types of strains. First one is tensile or longitudinal strain. Tensile strain is what? It is defined as change in length to the original length. So change in length is small l and original length is capital L. So tensile strain is equal to small l upon capital L. Volumetric strain. Volumetric strain is equal to, it is the ratio of change in volume to the original volume, and that change in volume is dV and original volume is V. So formula volumetric strain is equal to dV upon V. Shearing strain is equal shearing strain or shear strain. So shear strain is equal to lateral displacement of any layer to the its distance from fixed layer. So lateral displacement is AA dash upon fixed layer is AD. So it is equal to tan theta, and that tan theta is equal to, if theta is very small, so tan theta is equal to only theta. This is elastic limit. The elastic limit is the maximum stress of a body can experience without becoming permanently deformed. Now Hooke's law. Within elastic limit, stress is directly proportional to strain. So stress is directly proportional to strain means stress is equal to constant into strain. and that constant is stress upon strain is equal to constant, and that constant is equal to modulus of elasticity.